Hello and welcome to this video on the quadratic formula. In a previous video, we looked at how to solve quadratic equations by finding the x-intercepts. We saw how to do this using Desmos, so graphically, and we saw how to do this using the null factor law by first factorizing the equation and then using the null factor law to find the two x-intercepts. There will be a lot of quadratic equations you come across where the null factor law won't work for them. And if you haven't got access to Desmos or to a graphing solution, then you're going to have to use something else. In that case, we use the quadratic formula. The quadratic formula is a magical formula that will work on all quadratic equations. It will tell you whether there are two x-intercepts, one x-intercept, no x-intercepts, and it will tell you what they are. As we know, the general formula for a quadratic equation is y equals ax squared plus bx plus c. Now these a, b, and c values here, a, b, and c's, they are constants. You'll always be given a number in those sections. If it's not there at all, then the value for that number is 0. So if there's nothing there at all, then it is 0. But it could be 0, it could be 1, it could be a decimal, it could be anything. It could also be a negative. So the value for b could be -2 or -3. The value for c could be -2, -3, -60. Like, it could be any number, positive or negative. These a, b, and c values. And they're the values that we use in our quadratic formula. So our quadratic formula gives us the value for both of our x-intercepts, x1 and x2. And the formula goes like this. We start with negative b, but we put the b in brackets. The reason we put the b in the brackets is in case there is a negative value for b, we want to put that negative value inside the brackets with a negative on the outside. So it's a double negative in that case. Negative b plus the square root, we do the square root sign of b in brackets again, squared, minus 4, and the 4 is always there, times a times c. And that is all on the square root. And then all of that is divided by 2 times a. All of that is divided by 2 times a. So we have negative b plus the square root of b squared minus 4 times a times c over 2a. Now our second x-intercept that we can find with this, I'll write it out. We start with negative b in brackets minus the square root of b squared minus 4 times a times c. All of that is in the square root. And this is all divided by 2 times a. Now I wonder if you can spot the difference here between these two. If you saw that there's a plus here and there's a minus here, you're exactly correct. That is the only difference. So in your calculator, when you go through, you do this first one, and then you go back into it and change that plus to a minus to get your second value. So let's do a practice question right now. First thing I want to do is write out what my values for a, b, and c are. So a equals, b equals, c equals. Now a is this first one here. Comes first, it's that first one, and it is +2. B is the second one, and b is -3. And c is the third one, and c is -2. Now that I have those, I can write my formula. So x1 equals negative b plus the square root of b squared minus 4 times A times C over 2 times A. And now we can fill that in with our values that we have in blue on the left. So negative B, I'll write negative, and B is equal to negative 3. So I'll write negative 3 inside those brackets. So we have negative on the outside because that's part of the formula, and we have a negative on the inside because that's what B is. It is negative 3. Plus the square root of negative 3 in brackets again, squared, minus 4, the 4 is part of the formula, times A, which is 2, times C, which is negative 2. All of that is square root over 2, because that's part of the formula, times A, which is 2. I'll put this into my calculator. So I'm going to start with a fraction, negative 3 plus square root of bracket negative 3 close bracket squared. Take 4 times 2 times negative 2 over 2 times 2. So we've got my negative 3's inside the bracket. We have negative 4 times 2 times negative 2, and all of that is over 2 times 2 equals, and this equals 2. So x1 equals 2. Now we do the same thing with x2 to find our second x-intercept. Remember that the formula is exactly the same, except that instead of being plus, we are minusing. So we go negative b minus the square root of b squared minus 4 times a times c. All of that is over 2 times a. So now we write in our values. So this equals negative, b is equal to negative 3 still, minus, we're doing a minus now, square root of b, which is negative 3, in brackets, squared, minus 4 times a, which is 2, times times c, which is negative 2. So it's still all exactly the same, over 2 times a, which is 2. When we put this into our calculator, and if you look, I've got the exact same thing still in my calculator from the last time. I can go back into this formula. I can go back into this formula and travel to this plus, change the plus to a minus, press enter, and it gives me negative 1/2, which negative 1/2 is equal to negative 0.5. So those are my two x-intercepts. And if we go into Desmos, and I open this up in Desmos, you can see here on Desmos that this exact equation, when we graph it and look at it graphically, there is an x-intercept here at negative 0.5, and there is an x-intercept here at x equals 2. And that's exactly what our quadratic formulas gave us. X equals 2 and x equals negative 0.5. Alright, for the next one, we are going to go y equals 3x squared plus 6x plus 3. So first I write out my values for a, b, and c. And we have a equals 3. A is that first one, a equals 3. B is the second one, b equals 6. And c is the third one, c equals 3. Nice and easy, no negatives. So now we shall go with x1 equals negative b plus the square root of b squared minus 4 times a times c. All of that is over 2 times a. So that means that x1 equals, and now I'm going to put my values in, negative b, which equals 6, plus the square root of b squared minus 4 times a, which is 3, times c, which is 3. All of that is on a square root. Then it's divided by 2 times a, which is 3. So we've got 6's, we've got 3's, 6's and 3's. Put that into our calculator. We have, start with a fraction, negative 6 plus the square root of 6 squared minus 4 times 3 over 2 times 3. And that equals negative 1. So x1 equals negative 1. So what does x2 equal? Well, remember that it is the exact same, except we change that plus to a minus. So x2 equals, and I'll do it over here, negative 6 minus, we do minus instead, square root of 6 squared minus 4 times 3 times 3 times, running out of space, 3. All of that is over 2 times a, which is 3. So x2 equals, and when I put that in my calculator, once again, I just go back into the equation and I change that plus to a minus, equals, and it also equals negative 1. Now, because both of these equal negative 1, that means that there is only one solution. There is only one x-intercept. It doesn't hit negative 1 twice. It hits negative 1 once. There is only one solution at x equals negative 1. If we look on Desmos to check our answers, we can see on the left here, I've got 3x squared plus 6x plus 3. And on the right, you can see it comes down, hits negative 1 once, and goes back up again. So there is one x-intercept at negative 1. If I zoom in on this, doesn't matter how much I zoom on this, you can just see that there is one x-intercept. Comes down, hits negative 1, and goes back up again. So there is only one solution, and this formula tells you that. This one will be 4x squared plus 1. Now, there is a chance that you may get a question like this, and there is one small trick to it. First, once again, we go a equals, b equals, and c equals, and we want to know what these three values are. Now, a is our first one. It is connected to our x squared, so a equals 4. B, now b, if we go up to our previous questions, b was always connected to this x here. And up one more, b was connected to this x on its own here. But we haven't got an x on its own. We just have this x squared. We have an x squared here, and then we have no x. There's no single x in this. And that means that there is no b value. So if there's no b value, then we write b equals 0. It's not there, so there's no b value. And c is this one that has no x connected to it. There's no x there. That is our c value. So c is equal to 1. So A, B, and C. And now we use the same formula. x1 equals negative b plus the square root of b squared, keeping the b in brackets, minus 4 times a times c. All of this is over 2 times a. So when I write my numbers in, we have negative 0, because b is equal to 0. And that can be okay sometimes. Sometimes that will be okay. Plus the square root of 0 squared. Again, it's okay. Minus 4 times 4 times 1. 4 times 4 times 1. All of that is in the square root, and then we divide everything by 2 times a, which is 4, and we see what this equals. x1 equals. So on my calculator, again, I start with a fraction, negative 0 plus the square root of 0 squared minus 4 times 1 over 2 times 4. I press equals, and I get this error. Now, if you were to get an error that was something similar to this, or it could just say math error, all right, what that error means, is that this set of numbers, this set of a, b, and c values, creates an equation, creates a graph where there is no x-intercept. These three values that we have for a, b, and c create a graph where there are no x-intercepts. So my solution to this then, my answer, I write, is no solutions. No solutions, or no x-intercepts. Now you might be wondering, oh, well, what about the other part of the formula where we have a negative instead of a positive? Well, let's check that. If I go back into here and I change my positive here for a negative and I go equals, nope, we get the exact same problem. Just an error. So there are no solutions for this. If we check Desmos to see what's happening, visually, you can see on the left, I've got 4x squared plus 1. On the right here, we come down, we hit 1 on the y-intercept, and then we go back up again. And at no point do we get anywhere close to this x-axis. So because we don't get close to this x-axis, that means there are no x-intercepts. So the formula told us that there were no x-intercepts, and so we can write no solutions or no x-intercepts. Now looking back on Desmos, this doesn't mean that if one of these numbers is 0, that there will be no x-intercepts. For example, this one here, where we have 4x squared take 1, there's still no b value here, so b is still 0, c is negative 1, and a is positive 4. And if you look on the right, you can see that there are x-intercepts here. There's one at negative 0.5, and there's one at positive 0.5. So just because we are missing a value, A, B, or C, doesn't mean that there is no x-intercepts. We could also have an equation where there is a value for everything. So there is a negative B, there is an A, and there is a C. This also gives you no x-intercepts. If you were to put these A, B, and C values into the quadratic equation, you'll get the exact same problem. You'll get the exact same error on your calculator. No solutions, no x-intercepts. All right, that is all we have time for in this video today. I hope you have learned how to use the quadratic formula and you'll be comfortable using it. Have a go at your own questions, make up your own values for A, B, and C, and see how you go.